Hello. Today we're going to be talking about solving equations using quadratic techniques. So we're going to look at equations that are bigger than quadratics, but look an awful lot like them. So if I look here in example 1, it's a trinomial, and it looks like a quadratic. It's even exponent, but we can treat it like a quadratic and solve it. Let me explain just a little bit easier. If I picked a quadratic, how would you solve x squared plus 5x plus 6 equals 0? The easiest way, and we have lots of ways to solve it, we could factor it. So if I can factor it into two things multiplying together to make a 0, that's what I would do. So I know x times x makes my x squared. And as far as options of making 6, it's either a 1 times 6 or it's a 2 times 3. Which one's going to add to make that 5? It's going to be that 2 times 3. 2 times 3 makes 6, but adds to make 5x. And so since it's a positive 6 and it's a positive in front of the 5, I know both of these have to be pluses. Now if I do a quick double check of my inside-outside, I have 2x's plus 3x's definitely make 5x's. Okay, so I know it's factored correctly. And if it's factored correctly, then I can look at this and solve it by saying if they're multiplied together, and if it equals 0, then either x plus 2 equals 0, or x plus 3 has to equal 0. Because the only way that you can multiply to get two things multiplied together to make it equal 0 is if one of them equals 0 or the other equals 0. So that's solving by factoring. Okay, now that I have it here, I can solve it and go minus 2, and x equals negative 2. Or minus 3, x equals negative 3. Now, what if I didn't have something like that? We've solved quadratics before. How could I take this fourth degree? Well, what if instead it's still a trinomial? Could I factor it? What if I took and said, instead of x times x makes x squared, what if I said x squared times x squared? Would that make x to the fourth? Sure would. What about 6? Could I still use that 1 times 6 or 2 times 3 and say, well, it's going to end up making this 5x, so let's put a 2 and a 3. And also say, because they're both positives, there have to be pluses? Sure. Does 2x squared plus 3x squared make 5x squared? Sure does. So it is factored correct. And so now, because they're multiplied, I can say that x squared plus 2 has to equal a 0, or x squared plus 3 has to equal a 0. Because they're multiplied together, and that equals 0. So that's the only way. Either one's a 0, or the other's a 0, or both. But now that I split it into these two equaling 0, I can then solve it this way. Minus 2 to both sides, minus 2, just like I did. But then I end up with an x squared equals a negative 2. Or, which if I want to solve that a little bit more, I can square root both sides. Don't forget, when I square root both sides, you have to have plus and minus. But it's a negative 2 in there. That means I got to take out an I. And so your answer would be x equals both positive I squared to 2 and negative I squared to 2. Same thing over here. What if I minus 3 to both sides? So x squared equals minus 3. We're going to square root both sides. And it's a negative inside of a square root. So we're not going to have a real solution. There's no real solutions. We're going to have I square roots of 3. And so there are 4 solutions that we could have for this fourth degree polynomial. So if you remember back, there can be up to 4 solutions for a fourth degree polynomial. These two, if I graph it, it's not going to cross that x-axis, and so that's why we're getting imaginary answers, which is still a solution. So first of all, how can I know when we can do this? Now, if I wanted to use the quadratic formula, I could have done that. There's any way of solving it, you can write it, but you have to be able to know how to look at it so that it is in. And so what the book describes is, think of it as x squared squared. So if I can have some value that I can stick in a something squared and then have a something after that, then you can write it as a squared. But these two have to be the same. So yes, that can be written as a quadratic. The sixth could also be written as a quadratic as well. Where we're going to run into problems is this part C, because for this to happen, this 12, to make it the same, x squared minus x squared here. You see how for these two, to be the same, this is not going to make that x to the 8th. So that cannot be written in quadratic form. But even this 1/2 stuff can. So if I have an x to the 1/2 and I square x to the 1/2, that's going to get me that same plain old x that it began with. So even those x to the 1/2 powers could actually be. Your identifier, if you're like, well, what should go in those parentheses? Look in the middle term. That almost tells you all the time. And if it doesn't work, then it cannot be written in quadratic form. Okay? So then when you solve these equations, you can write it, if it can be written in quadratic form, you can solve it any way you want. So maybe I want to take this trinomial and factor it into this x squared minus 9 times x squared minus 4. Well, x squared minus 9 can be factored to an x plus 3x minus 3, and the x squared, this x squared minus 4 can be an x minus 2x plus 2. If they're all multiplied together, then equals 0, then using that zero product property, you can split it up into 1, 2, 3, 4 equations, in which case x equals either 3, negative 3, 2, or negative 2, and you get all 4 answers. So let's work on this a little bit. Write each expression in quadratic form if possible. Start with the middle. Look at this middle term here, y cubed. So can I write it so that y cubed, 7y cubed minus 8 plus 5 times something squared. So can I put a y cubed, the exact same thing that I put here, can I put it in this and have it equal this y to the 4th? Y cubed squared is going to be a y to the 6th. That means this one right here, not possible. Number 5 is possible because looking, now this is like looking at it as though it's a plus 0, but this term is an n squared. Is it possible for me to have an n squared and an n squared squared up there and have it still turn out to make this n to the 4th? So I can still write the 84 out here, minus 62, and if you want to tack on that plus 0, that's okay. But yes, this does work. So then this is written in quadratic form. So to solve these equations, use anything in your disposal to solve a quadratic. If I'm factoring, do you notice how all 3 of them have an x? That means I can factor an x out and get an x squared plus 9x plus 20. Now it actually is a quadratic, and you can factor that as well. And then you can break it up into 3 pieces to solve it. So what would that be? Plus 5 plus 4, 5x, 5x and 4x. Yep, that makes 9x. So then each one of these could equal 0. So either x equals 0, x plus 5 equals 0, or that would be a negative 5, or a negative 4 plus 4 makes 0. So these would be my 3 answers to that same problem. If you want to plug in and just factor this thing, Go for it. It will. And then solve it just like the first example. Don't forget that we have difference of cubes. So number 8 here looks an awful lot like a perfect cube, which means that would be an x. Cube root of x cubed is x. Cube root of 216 is 6. Keep the same sign. Square the x, you get an x squared. Square the 6, you get a 36. It's always a plus. Take the opposite sign of what was in there and then multiply those two together, and that ends up looking like a 6x equals 0. Now, one thing about this is it looks like, now that is quadratic, but this never factors. So you're going to have to put this in the quadratic formula. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a. That's what you're going to need to do this part. However, this one could equal a 0. So x minus 6 could equal 0, in which case plus 6 plus 6, x equals 6. So this is one solution. Put these into your quadratic formula and get x equals something plus and minus to find your other solution. Good luck. Hope this helps. Have a great day.